I don't know. Check.
All right. So for number 2, did you get the first one?
Yeah.
Sweet. All right. Number 3. Researchers at the University of Mississippi wanted to determine whether the reaction time in seconds to go, no-go stimulus of males differed from that of females. Researchers randomly selected 20 females and 15 males to participate. The go, no-go stimulus required the students to respond to a particular stimulus and not to respond to other stimuli. The researchers decided to construct a confidence interval to determine if the difference of the means is significant. To determine whether a confidence interval would be reliable, they create Q-Q plots of both random samples and see they are approximately normal. Are the requirements for constructing a confidence interval satisfied? Why or why not?
Okay. So.
Did you get number 2 or B?
Yeah.
Okay. Good. 2.
The distribution of community sample is normal since the data have been determined.
Mm-hmm.
Yeah.
Sweet.
Mm-hmm.
Oh, I can hear your child.
Yeah, I'm trying to feed him. I didn't want. I turned my video off so I could hear him really quick.
Oh, okay. No worries. That's fine. I wouldn't have even thought about that. Of the 4 types of confidence intervals listed below, which one is appropriate for this experiment? Confidence interval for mu when sigma is known. Confidence interval for mu when sigma is unknown. Confidence interval for the mean of differences using dependent samples. Confidence interval for the difference of means using dependent samples. So I have a list of all the requirements and the stuff that would be best. And I think, to me, it looks like we don't know the sigma. Like, we know a lot, but I don't think that we know the sigma. And so I would either say when the sigma is unknown or using independent samples.
I said using independent samples just because like they are independent samples and that's the only research me.
Yeah, it fits better with using independent samples than it does with sigma unknown.
Yeah, they didn't really give us any other information.
I agree with that. Alright. A researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the saving account balance of a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of bank customers is found to be that. Which of the following would produce a confidence interval with a smaller margin of error than the 95% confidence interval?
The second one, bigger sample size.
The second one, what?
So when you have a bigger sample size, it has everything to do with how big the sample size is.
Yeah, it does.
So if you make a bigger sample size, it will produce a smaller margin of error.
I agree with that.
That's what.
I agree with that. Alright. A factory makes a propeller drive shaft for ships. A quality assurance engineer at the factory needs to estimate the true mean length of the shafts. She randomly selects 4 drive shafts made at the factory, measures their lengths, and finds their sample mean to be 1,000 millimeters. The lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculate a 95% confidence interval for the true mean length of the shafts.
Okay. That would be plus and minus.
Yeah.
1,000 plus or minus 1.96 because it's the 95% confidence interval.
Mm-hmm.
2 divided by the square root of 4. That is our sample size.
Plus 1.96 times
2 divided by third of 4.
Divided by what?
The third of 4.
Okay.
Because there's, yeah, she randomly selected 4 drive shafts.
All right, so the answer is going to be number 1, 1001.96.
Yep.
Do we want to check the lower one or do we trust it?
I got the lower one, and it's the 998.
Oh, okay, good. Sweet. Awesome.
7. To assess the accuracy of a lab scale, a standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times, and the mean of the weighing is computed. Suppose the scale readings are normally distributed with unknown mean, mu, and standard deviation of 0.01 grams. How large should n be for the 95% confidence interval for mu has a margin of error of 0.0001? So for this one, it's that sample size formula.
Mm-hmm.
So it's the n equals v star times sigma divided by m, and then you square it.
Yeah, I have that one.
So I got 38416.
All right, I haven't actually done it yet. 1 second. All right, I might be making this harder than it has to be. So you take the z score times the sigma.
Yep, so 1.96 times 0.01,
Mm-hmm.
and you divide it by 0.0001.
How? Oh, because the margin of error. Duh. That's why.
Oh yeah, the margin of the 0.001.
That would probably be what happened there. All right, I got 1960.
And then you gotta square it.
Oh, duh. Okay, you're right. 416. Okay, good. All right, the mean area mu of the several thousand apartments in the new development is advertised. Am I wrong, or are these like the same ones we found on our homework? Like the exact same ones? I thought so.
Yeah,
The mean area mu of the several thousand apartments in a new development is advertised to be 1250 square feet. A tenant group thinks the apartments are smaller than advertised. They hire an engineer to measure the random sample of apartments to test their suspicion. The appropriate null and alternative hypothesis, null and alternative for mu are.
so I got the first one.
Because they want to know if they are smaller than advertised.
Mm-hmm.
Yeah, that makes sense. I agree. In a statistical test of hypothesis, we say the data are statistically significant at a level of significance if
I got
the
the
P
one
is less than A. Yeah, that's what.
because that rule with that big long one. So.
Yeah, that rule confuses the crap out of me, but I
That's
do.
me too. I freaking hate it. I
I
read it
do.
like 80 times when I do this.
Yeah, it always makes me nervous. I'm not sure why.
It talks about the null and the alternative, and you have to make sure you're comparing the right one.
That's true.
Okay, I'll do 10 here. Okay, a group of statistics students want to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample size of 15 of each of 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal. And they use an ANOVA hypothesis test to answer their question.
So the requirements for an ANOVA are that the data are normally distributed in each group, so 15 from each would be normal. We don't know anything about the QQ plots. The sample size is smaller than 30 for each group, and the sample variance is less than or equal to 4 times the smallest sample variance.
Right.
So I would say that yes, and I would say number 1.
Yeah, because it tells us that they're all bell-shaped, that there are no outliers, and that the sample variances are nearly equal, and that's all that really matters.
Yep.
So, cool. Number 11.
All right. A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that the average survival time after diagnosis is the same. Oh, hang on, I gotta process that. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that the average survival time after diagnosis is the same for the new treatment and the standard treatment. In an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at the 0.05 significance level. Consequently, she rejects the null. In a future study, she determined that the new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer. The researcher has committed. Oh, crap.
I had to pull my table out.
Yeah, man, I don't remember. I know that there's one that's like.
I think this is like one error. Because when you look at like the table, hold on. So she rejected the null hypothesis, and okay.
I remember what the rules are, I just don't remember which one goes to which type.
So, well, if it was a
So there was like fail to reject the null when the null is actually.
So she rejected the null, right?
Mm-hmm.
And then H0 is the null. So H0.
Yeah, H0 is the null. So if she had failed to reject the null, then she would have been right, because that would mean that she thought the null was correct.
Right. And then, but so she failed to reject the null, and the null is true, is used the right decision.
Right, but because she rejected the null and the null was correct, then it would be a type 1. Okay, that makes sense. Because the type 2 would be that she thought it was correct when it wasn't, so she would have failed to reject the null, and it was actually wrong.
Exactly.
Okay, that makes sense.
Cool. Okay, so for 12 it says, if the level of significance A is made very, very small, thereby making the probability of committing a type 1 error very small. What happens to the probability of committing a type 2 error?
I think it was the last one. Didn't we decide that if you upped one, the other one went down, and if you put one down, it increased the other one?
In the book, it says if the A value is very small, or the probability of committing a type 1 error is very small, the probability of committing a type 2 error will be large.
Okay, so the last one then.
Yep.
So we're right. So that rule is still in place. If one goes up, the other will go down, and vice versa. I think that sucks because you're just gonna make an error no matter what.
Yep.
The nicotine content in cigarettes of a certain brand is normally distributed with a mean in milligrams mu and a known standard deviation of 0.17. The brand advertises that the mean nicotine content of its cigarettes is 1.5, but measurements on a random sample of 100 cigarettes of this brand give a sample mean of X bar equals 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this, test the hypothesis. Null mu equals 1.5. Null alternative mu is greater than 1.5.
Okay, so we know they give us the sample mean.
They do. And it's 1.53. So it is greater. So the null is that it would be 1.5. This said that it was not. It says the measurements say that it was 1.53. So you would reject the null, wouldn't you? At the 5% level of significance, you would conclude that.
Okay. Okay. It's normally distributed. We know that with mean and a known standard deviation of 0.1.
Because you wouldn't reject the alternative because the alternative is actually true. And you wouldn't fail to reject the null because the null is wrong. The 5% chance of the null hypothesis is true doesn't even make sense. It's not relevant. So wouldn't you reject the null?
I think so.
Okay.
That's what makes sense.
That's what makes sense to me. If we get it wrong, I'll be really confused.
Oh.
But the ones you get wrong, those are the ones that you need to study. So on the bright side, this is very helpful.
Hopefully.
Yeah.
All of them right.
Yeah, that would be the best.
I know that's not gonna happen then.
Do you gotta go soon? Because it's 8:53.
Yeah, I'll like 8:57.
Okay.
Do that, like hop off and then hop on. It only has to be 30 minutes long, so hopefully it won't be like drag on. It's really dumb.
Okay, I'll probably keep working on this and just see if by the time we get back on, if we can just run through it, because I know we both got stuff to do.
Like 3.
All right. Yeah.
I don't
yeah, I don't either. You would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? Independent sample t-test? Oh, wait a minute. 100 for each group? Maybe ANOVA.
Well, we're looking at the mean number of hours worked for wages per week. And also you would like to a random sample of 100 for each group. So we're comparing 2 different sets of data.
Yeah, so it wouldn't be one sample, and they're not paired. It would. I think it would be independent because ANOVA is if there's more than 2, isn't it?
Yeah.
Okay. All right. I think it's independent then.
15. An educator she decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brother, sister parents, and Should students also teach independent or dependent?
Oh, definitely dependent.
Yeah, because they are totally dependent.
What?
Yeah, absolutely.
Oh my god!
So the sisters' academic achievement depends to some degree on their brothers. If you select a brother so as to compare his academic to his sister, you must include. Oh yeah, definitely the last one.
Last one, right?
The sister's academic achievement depends on some degree of her brothers. Well, crap.
Uh-huh.
I have brothers. That's not true at all. You don't have to take statistics to know that's a bunch of crap.
You don't get in trouble if that was true,
Yeah. A soil scientist collected random soil samples from a field and measured the dissolved organic carbon level of each sample. The researcher would like to construct a 95% confidence interval for the mean dissolved organic carbon level in the field. Open the data file, dissolved organic carbon. Use this information to answer questions 16 and 17. Dissolved organic carbon. We might want to stop there.
Yeah. So I'm gonna save this really quick. I'm gonna hop onto my other meeting now. Should I just text you when I'm done?
Yeah, just text me and then I'll hop back on here.
Okay. Sounds good. Then I will see you in the next meeting.
All right, sounds good, Sheree. Peace. Okay, instead of saying end the broadcast, it says post publicly. I don't know what to think about that. I don't really want to post it, you know? You know what I'm saying? I don't know. Oh, well, there we go. Oh, I never did it live. Even though it said live. That can't be true. It said live.